In this lesson, we're going to go over basic trigonometry. So we're going to review sine, cosine, and tangent. A sine of an angle, cosine of an angle, and tangent of an angle represent ratios of sides of a right triangle. So if we're given an angle and one side, we can use one of these trigonometric functions to find one of the other sides. So, for example, sine of an angle will give us the ratio of the opposite side to the hypotenuse. And I'm going to review how we determine which side is the opposite and what side is the hypotenuse as well. Cosine of an angle will give us the ratio of the adjacent side to the hypotenuse. And tangent of an angle will give us the ratio of the opposite side to the adjacent. One way to memorize how to set up these ratios is by memorizing SOHCAHTOA. So sine is opposite over hypotenuse, so. Ka stands for cosine is adjacent over hypotenuse, and toa stands for tangent is opposite over adjacent. SOHCAHTOA. Okay, now let's see how this actually gets put to work. So let's make a right triangle. Say this is the angle theta, and then let's define the sides. So first of all, the side opposite the right angle, so the side across from the right angle, is the hypotenuse. Okay, and just like the hypotenuse is opposite the right angle, the opposite side is opposite the angle we're looking at. Opposite of theta is the opposite side. And adjacent means next to. So here's theta. The side next to it is this side. And also this side is next to it. But this side is, of course, the hypotenuse. So adjacent means this side. So let's look at this example. We have a right triangle. We're given that this angle is 30. This side is 4. And we're searching for the hypotenuse. Okay, so if we had this other side, we could just do Pythagorean theorem. But we're missing this side, so we can't. Instead, we're going to have to use one of the trigonometric relationships to figure out what the hypotenuse is. So a good place to start is by writing out SOHCAHTOA, so you can determine which one we're going to use. Okay, now let's figure out what sides we have. 4 is across from the angle, so that's the opposite side. X, which we're looking for, is across from the right angle, so that's the hypotenuse. So we have the opposite side and we need the hypotenuse, so we're going to have to use sine, because sine has opposite and hypotenuse in it. So we'll start by writing sine of the angle theta equals opposite over hypotenuse. Now let's plug it in. Sine 30 equals 4 over x. sine of 30 is 0.5. You could find this out from your calculator, or you might just memorize sine 30 is 1/2. So we really have 0.5 equals 4x. Okay, to get rid of the x, this is 4 divided by x, so let's multiply both sides by x. So I'll just continue this up here. 0.5x equals 4. These x's cancel. Okay, now divide by 0.5. And we end up with x equals 8. So this should make sense because sine of 30 is 0.5. So that means opposite over hypotenuse has to be 0.5. 4 over 8 is 0.5. So it does make sense in the end. So when we're solving for one of the missing sides, if we have an angle and we're given a side, we can easily find the other side by using sine, cosine, or tangent. We just have to first identify what sides we're given. And then we can just write the formula, plug it in, and solve.